Okay, so there are instances when we can use the Poisson distribution more effectively than the binomial distribution as an approximation to the binomial distribution. So if certain conditions are met, which are if you have a binomial distribution and n is large, typically larger than 50, and p is small, typically larger than 0.1, smaller than 0.1, then the lambda part of it becomes the expectation NP. So let's take a look at this example. The probability that a wrapped chocolate biscuit is double wrapped is 0.01. Use a suitable approximation to find the probability that the next 60 biscuits that you unwrapped, none are double wrapped, at least 2 are double wrapped. So this is a binomial distribution because you've got a fixed number of trials, 60, and you've got a clear probability of success, and if it's not a success, it's a failure. So it's a binomial distribution. So if we say let x represent the number of biscuits that are double wrapped. N is bigger than 50 and P is less than 0.1. So therefore X, which is binomial 60 0.01, will approximate to a Poisson distribution, and the mean is going to be NP, which is going to be 0.6. So because n is large, p is small, it is a binomial distribution, but we can approximate using that. So for part A, probability none are double wrapped, x equals 0, so we can just plonk that into our Poisson distribution, which is e to the minus lambda, so e to the minus 0.6, 0.6 to the power of 0 over 0 factorial, that's 1, so we got e to the minus 0.6 0.549. And part B, at least 2 are double wrapped. So if at least 2 are double wrapped, then that includes 2. So we're saying the probability that x is greater than or equal to 2. I can't pull off a cumulative greater than or equal to, so I've got to pull off 1 minus, and for us to include the 2 value, I've got to pull off less than or equal to 1. So going into my tables, menu 7, page 2, Poisson cumulative, variable, x is 1, lambda is 0.6. 0.878, store that in x, go back to the arithmetic screen, 1 minus x equals 0.122. 0.122. So that's approximating a binomial distribution using Poisson.